Okay, let's solve question number 21 from the study guide for week 1. So we'll just set it up. Here's question number 21. And the first thing we want to do is write down the information that we're given. So we're given that the initial velocity is 0 meters per second. We're also given that the final velocity is 50 meters per second. And keep in mind that this final velocity is the takeoff speed. So we're going to write this down. Even if you think you know this in your head, which I know you do, is just given information, write it down. The technique to solving all these problems really is to write stuff down. We also know that the acceleration is 4 meters per second squared. So question A asks us, what is the time to get to takeoff speed? So we know that takeoff speed is 50 meters per second. We know the acceleration is 4 meters per second squared. So what is the amount of time needed to get to takeoff speed? That's part A. Then part B, once you get the amount of time needed to get to takeoff speed, how much runway is needed? So B is, what's the length of your runway? All right, that acceleration equals final velocity minus initial velocity over time. And again, we know VF, the final velocity is 50 meters per second. We know the initial velocity is 0. We know the acceleration is 4 meters per second squared. Now, we need to know what the time is to get to takeoff speed. So all we're going to do is rearrange this formula for acceleration and solve for time instead. So we rearrange the formula, and that means we're going to get time equals VF minus VI over A. Just doing some algebra, flipping it around, solving for T. Now we just plug and chug. So time equals VF, and remember VF is 50 meters per second, minus VI, which is 0 meters per second, over acceleration, which is 4 meters per second squared. We just do the math, and so we get 12.5 seconds. That is the amount of time needed to get to takeoff speed of 50 meters per second, right? No problem. So we've got A down. Now let's take a look at B. B is a little bit more challenging, but again, it's just about using the appropriate formula. So for B, recall that final velocity equals distance over time. So again, D is distance traveled. So let's write that down. D equals distance traveled. And then we're just going to solve this problem now, rearrange it to solve for D, because we're looking for the length of the runway. So we want to know the distance traveled in a certain amount of time going at a certain velocity. So distance equals final velocity times time. And again, we just plug in our numbers. We know the velocity is 50 meters per second. We know that the time is 12.5 seconds. And so the total amount of runway we need is 625 meters. And that's what we need in order for this airplane to take off. Now, you can actually solve this a slightly different way. Oftentimes, there's going to be more than one way to solve a problem. We know, for example, that we've got acceleration. And acceleration is simply velocity over time. Well, if we wanted to go this route, we have an acceleration, we have velocity. Remember, velocity is distance over time. So here, acceleration equals V. And remember, V is distance over time divided by time. So this is going to equal distance over time squared. And if we solve this equation for D, E equals D over T squared. So then distance equals A, acceleration, times time squared. We put in our numbers, 4 meters per second squared times 12.5 seconds squared, and the answer, 625 meters. So we get the same thing. Two ways to solve the same problem. Okay, so that's question number 21. And again, it's just a matter of picking the formula, following through with it, and you'll be good to go. If there's any questions, please just let me know.